Hello everyone, my name is Dhruv Sompura and I will be explaining Altair AI Studio and how I build my project. So I will show you my project first. This is what I have built, and I will be explaining how I went through it, and I will be building it side by side. Let's go, and first let's select the retrieve operator. Retrieve operator is used to retrieve the data set. You can click on import data, click on my computer, and wherever your data is present, this is my data file. You click on next. Here you can select the columns and the rows that you want. You click on next. Over here you can select what target variable that you want to have. For example, if distance is your target variable, then you click on settings, you click on change role, and then you can select label. But we don't need to do that here. We'll do it afterwards in the process. Over here you can go and click on change type and then click on polynomial, because for redcure it's detecting it as integer, but it's actually a polynomial because it's only considering 100 rows. If you go beyond 100 rows, it becomes a polynomial because there are other alphabets as well. You click on next, and it says where to store data. You click on data, and then it will be stored. You give it a name, it will be stored. But I've already imported it, so I won't do that. I can click over here, click on retrieve operator, click on this, and click on data, and then click on your data that you first will add trim. Trim removes the white spaces from the data. Then we click on filter examples. Now filter examples is used to filter out the attributes that you want to. Like over here we can go and click on, let's say I want to filter out the sex column. I can click on does not is not missing, so the values where sex is missing will not be considered. So I can either click on OK, I can click on add entry, and I can select any other field, or I can just click OK. So it filters your examples. Then I clicked on remove duplicates, which removes all the duplicate entries, and I selected attribute filter type as all, so that if all the columns in a single row are similar to another row, then the second row will be removed. Then I clicked on set role. As I said, set role is used to select the label for me. I selected target as the label. This will be my target column. I clicked on remove useless attributes. It removes the attributes which have nominal useless over 1.0. I also clicked on nominal remove id like, which removes the id like values. Like in my data set I have a column which only has IDs. Then I created a correlation matrix. Correlation matrix is used to remove correlated attributes. Attributes which have correlation means two attributes which are very similar and give very similar results. Finally, I normalize the data using Z transformation. You can select all of this, and then you can put them in a sub process. You can select a sub process from here. You can get a sub process. You can select all of this, and then you can drag and put them in a sub process, and then you can rename that sub process. So that's what I did. Then I went and clicked. I got a multiply operator. Multiply operator separates out the results that you get from the previous operator, and I put one in compare ROCs and second one in optimize parameters. In compare ROCs, I used a decision tree. I made a lot of models like decision tree, random forest, gradient boost, generalized linear, GLM, KNN, and naive Bayes. I also built a stacking model. Stacking model you can select from here. Stacking can be selected from here, dragged and dropped from here. You can open stacking, and then you can select your two models, random forest, naive Bayes, and these are my base learners, and stacking model learner is decision tree. These are actually the models that perform the best for me, which was done by running this ROC without this stacking. I also use this recall and set parameters, which I will explain to you. First, let's talk about optimizing parameters. Optimizing parameters, first let's talk about what's there inside the optimizing parameters. I'm using this to do hyperparameter tuning and select the best parameters for the best results. So let's start with decision tree. So you click and drag first cross validation operator. In cross validation you put your model, then you put apply model, and then you put performance. So this will apply decision tree and give performance results. In cross validation you select the number of folds and you select the sampling type, and you can enable parallel execution to fasten the process. And then you put it in an optimized parameters, which optimized parameters is used to optimize the parameter into hyperparameter tuning. You can select whatever operator that you want to optimize. You can click on this, then you can click on something, you can click this button, it will come here, and when you click on this button, all those things that need to be optimized will be shown here. And you can also it is important to know that more parameters you select, the more time it will take for a process to run. For my project has a lot of models and lot of and one ensemble model, so it will take a lot of time for me to run, so I selected just one parameter. Over here as well I made something for random forest, and as you can see I've optimized the parameters. I took this random forest 2 criterion, one of 4 combinations are selected, and so on. Over here I did with naive Bayes only 2 are there, true and false, so it doesn't take a lot of time. Over here I did it with stacking stacking is there over here. Random forest, naive Bayes, and decision tree is the learner. In stacking I have optimized the parameter as keep all attributes and keep all confidences, and you can select these 2 things, but it takes 4 combinations only, it won't take a lot of time to run. You can put all of this inside a sub process, and over here you also optimize these 3 things, but this time round you select sub processes, select which you select this thing from here, so that it selects the sub processes which are the best out of all those models. So that's what it does, and you can put the numbers over here. If there are 3 models, you put 3, there are 4 or 4, so it does it for you. Okay, now I will run my model, my project. As you can see over here which processes are being run. It's showing optimized parameters grade 5 is being run right now, and it's showing how much percentage of running is done. So 66% is done, and it will do the rest as well. Now it's doing it for compare ROC. Something I'll show in compare ROC. As you can see, it's going to different models. It's going from gradient boosting trees to naive Bayes to stack. It will do it again. It's going to gradient boosted trees, naive Bayes, and stacking. So it will keep on doing it because it's a parallel execution. We'll skip to the end and show you the final result. This was the final result of my project. This is the ROC curve. The ones that are towards the top left are the ones that work the best. As you can see, this blue line is for stacking ROC, which worked the best for me. The red line which is hidden behind it is the random forest, which was the second best. Decision tree was the third or the 4th best. As you can see, it goes over this. I would say it's the 4th best, and GLM was the 3rd best. So you can select your models accordingly. There's naive Bayes as well, which is hidden behind the stacking, because naive Bayes worked almost as the best thing over here. Over here you can see the example set. Over here you can see the optimized parameters. It's showing you like this. Here you can see I got 100% accuracy, 100% precision, and almost everything was 100% for me. As you can see here, this is the description of the parameter set. These are the optimized parameters. So thank you.